Hello, hello. Welcome to Houdini Hangout. My name's Peter. I run the show here. Thank you so much for joining us tonight. And yeah, hopefully you have an interesting topic to go over this evening. Looking to try out some, um, like basically like a little flip waterfall, but the thing that I think will be interesting is adding in a like a custom field to that to help break it up as it's falling, so it's not just falling as these kind of strings almost, or like these like combined streams that really aren't breaking up at all. We want to give it some some life as it's falling. I'm also going to set up like a little cliff, which I think is kind of interesting as well. So what I'm actually going to do first, before I start anything else, is I'm actually going to launch one more version of Houdini here, just so I can keep second project open, so I can make sure that I'm not forgetting anything that I was kind of hoping to do. Messed around with this a little bit ahead of time just because it was a little bit more complicated than what I normally do, but shouldn't be anything too crazy. So I'm just going to move this over to my second monitor here. Oh, that's right. Have a dual screen setup that I usually use. So there we go. Okay, cool. Great. We are all set there. Cool. So hopefully that will be helpful if I get stuck on anything. So the first thing we'll do is make a cliff, basically, that this water is going to fall down. And then from there, we'll create an emitter and all that kind of stuff. For this specific setup, I'm going to be doing it in DOPS. I'm not going to be using the SOP flip, only because I'm a little bit more comfortable with the DOPS stuff, and I can kind of troubleshoot that a little bit better than the SOP-based stuff. So I think it'll just be a little easier for me to do it that way this time. It's possible that we could always play around with that and see how that could work as well. But since it's something I'm a little bit less familiar with just from years of using Flip and in DOPS, I'm just going to stick with that for this time. So yeah, so hopefully this will be an interesting topic and something that will be of use to you. Hey, Tom, howdy. How you doing? Glad to have you with us on the stream tonight. All right, so I guess the first thing we'll start off with is making a piece of geometry that we can have as a cliff. So let's just do this. We'll start with a geometry, and I'm just going to call this, just call it GeoCliff, and we will go inside of it there. So I'm just going to start out with something super simple, just like a box. And let's cut this up, because basically what I'm going to do is make like a little ridge around the top here, and I'm going to have it just have like a little like lower part here that it can the fluid can kind of build up in and then fall off the front. So we've got the box here. Let's set some sizes up here. So let's do this like, I don't know, I think like 5 meters in that direction. Actually, you know what? Probably like 10 meters actually makes more sense. It's like 30 feet, right? So this can probably be 5 meters deep. That should be fine. And then let's do this like, I don't know, I want it to be about 100 feet tall. I'm just thinking, I live by Niagara Falls, so I'm used to seeing a nice tall waterfall. So let's do that. That should be good. We'll just do the match size, because that's a nice quick way of getting it to the ground plane. Let's do minimum here. And there we go. We've got our setup going here. Wait, did I do that math wrong? It seems a little too tall. 90. Maybe we'll do this a little wider. Maybe this will be 10. I don't know, something like that. Yeah, that feels a little bit better. All right, so then let's go into our selection mode here, and hey, Zach, how's it going? Glad to have you on the stream this evening. So let's do this, make sure we're not selected anything. I'll just select all of those. And let's do edge divide. That should connect those all there. I'm going to connect those points, make sure the path is closed. Oh, also, remember to save. Remember to save. We'll just say, just call that waterfall. All right, so let's do 2 divisions here. That should be good. And then I am going to do a scale. I'm just going to scale those up. So we've got some edges like there maybe. And then I'm going to do the same thing this way. Just do an edge divide here. Select all these edges. Do an edge divide there. And for that, we only need 1. Oh, interesting. Did I not get that one? Let me see. No, I have that. Did something not connect properly here? Why are we missing this? That's weird. Huh. Weird. Okay, let me see. Let me see what I did here. Maybe I messed something up. Make sure I didn't forget anything there. No. No, everything seems fine. That's weird. Let's just take this again here and we'll select it again. Maybe I just messed it up. There we go. All right. That was weird. Must have just missed it. Anyways, so we'll just move this over here. I'm sure there's cleaner ways of doing this, but you know, we're just going to do something here. Nice and easy. Cool. All right. So then let's do, what is this? Let's see. Select, oops. That one. We'll do some extruding here. I'm just going to select these up at the top. Oh, yep. Right. We're getting stuff back there. So let's select these, and I'm just going to do a poly extrude here just to kind of make a little edge. Right? Cool. So we're just going to kind of fill this up, let it fall over. So we could obviously do it like this, right? This would be totally fine and whatever. But what I want to do is kind of make this a little bit more interesting, right? The better you can make your simulation geometry before you start, the better, you know, an end result you're going to get, basically. I'll make that back wall a little thicker. I don't like that. Just slide this forward a little. There we go. Cool. So I'm just going to noise this up. I kind of want to make this feel a little bit more like it's rocks or something like that. So let me turn these off. And let's do this. Let's do a VDB from polygons. So what I could do, first of all, let's talk about some options here. I've heard about this, first of all, this fast remesh. I'm just going to remesh this real quick. Yeah, that is very fast, actually. So cool. So we've got this mesh, right? And even if we were to do something like, say, you know, if we wanted to add some noise to this, right? So we've got this, and we've got a normal attribute. Where did that come in? Here, I guess, huh? I'm just going to turn that off because I'm going to add some normals on it myself. Just to get those. And then let's say we did like a mountain deformer or something like that, right? So we've got this mountain deformer, and so we've got this noise here, right? So as we add these noises in, right, and say we want to make the element size a little bigger, we start to get this really weird thing going on here, right? Because we've got, you know, this mesh that's got an edge and it's trying to push or pull in these two directions here, and it's kind of fighting itself, right? So we could do something like positive, right? But then we start to get these really weird stretched normals, and things start to intersect each other, right? So that starts to be a little bit weird. I was also playing around with the idea of poly bevel, right? And beveling these edges here. So what you can do is just exclude it to only to ignore the flat edges. We can do a distance of whatever. That's fine. Do a couple divisions here just so we've got a little bit extra. We could even probably go further than that, right? Something like that. Great. And then let's throw that into the fast remesh, right? Because that's going to now remesh those more smoothly like that. You know, maybe we even smooth this a little bit just to make sure that those triangles are a little, oh, that's weird. There we go. Let's do just something like that. That's fine. Okay, cool. So now we've got these smooth edges, right? But even still, if we do our normal and our mountain, it's okay, but we'll get some really weird results here, right? So like these will start to pinch in here or do, you know, any sort of number of weird things. Like if we made these more noisy, there's going to be all sorts of weird folds and stuff, right? So I was kind of playing around with this and I'm like, wait, this really isn't working well. Like there really should be a better way of doing this. I think there is, and we're going to mess around with that now. So instead of doing it with geometry, I was messing around with doing it with an SDF. And the good thing here, first of all, I'm going to turn this on. I'm just using world space for this narrowband. That just means the area around your VDB. So I'm going to change this to 1 and 1 just to give us a meter of kind of wiggle room here, right? So we have depth, or we have distance information out to a meter around this. That's just going to give us a little bit more room to kind of make some noise and stuff like that. And then if we do SDF noise, this is a newer node that I don't remember seeing before. I think it's either new. Oh, I don't know. It's either new in 19 or 19.5. It's a newer node, but give me 1 second. I'm going to have a little bit of beverage. It's pretty cool because this node will work on the SDF, right? And it's not really going to have those same issues of kind of folding on itself and all of those types of things. So we can see here we're starting to get a noisy result here, and this will work pretty much the exact same as the other one would. So we can adjust the amplitude a little bit here, right? We could adjust the element size. So for this one, I want the elements to be a little bit bigger. Let's do it. I don't know. Let's try like 5, something like that. Just a nice big element size. And let's do this at 1 maybe. And so there we're starting to get some nice bulgy stuff. It's kind of getting a little weird over here. Maybe that's a little too much. Maybe we'll do like 0.5 on those, something like that. Yeah, that's starting to look pretty good. So the one thing you want to be a little careful with this is this post-processing here, right? So I'm actually going to turn off the deactivate. And what that's going to do is what it normally does is it actually deactivates your voxels after the fact. So like if you're bringing in like a huge area and you're like doing all this noise stuff, it actually is trying to clean that up and deactivating those voxels. I actually don't want it to do that because I want to keep those values so that I can keep deforming it and doing all that kind of stuff. This renormalize is good because it's making sure that everything is in this kind of nice 0 to 1 range and giving you the distance and all that kind of stuff. So that's good, and we don't want to really mess with that too much. But so here we're starting to get this noisy kind of look going. So that's all seeming good. Let's see. Let's go maybe a little higher here. I want this to be a little bit more noisy, maybe. Cool. Yeah, something like that should be fine. And then what I'm going to do as well is maybe add in just 1 more noise here, maybe 2 more, depending on, you know, kind of how you want to mess with this. But I'm going to take this and keep basically the same settings, but I'm just going to change the amplitude here. I don't want this to be quite as high. Maybe we'll do it like half, and we'll change the element size to be like half as well. Now we are starting to run into some issues here because we're kind of pushing it maybe a little bit too hard. So let's go back a little bit here and just kind of play around with some of these values. So this starts to happen. Usually this was happening before with this deactivate off to make sure that that's not the case. Let me just push this a little further and make sure that that's not the issue. It's not the band voxels. That is odd. That's very odd. I don't know why that is specifically. Oh, I think what I had to do was change this. All right, going to the old help over here. Let me see how I had these set up. Let's see, amplitude 0.5. Yep. Okay, maybe I just pushed this first one a little too far. Okay, 0.5 and 5. And the next one I did with, let's see. Oh, here we go. That was the problem. It was trying to calculate the band voxels beforehand. And that's something we don't want it to do. So we're just going to say don't do that at all, please. Because we've already set the band voxels and we don't need to worry about that. So let's do 1 and 1 here. That should be fine. That was our problem. I knew there was one little thing that I was missing here. So what that was trying to do, I believe, is calculate that band voxels that we had set earlier. And each of these steps now it's trying to like recalculate that, right? But in this case, we don't really want it to do that. We want it to just keep the VDB that we're working with so we can kind of keep iterating on it. So that is the issue right there. And the cool thing is that it's using this displacement in much the same way as the other one did. It's using it on the normal. So it's actually calculating that normal based on the gradient of this SDF. So you can see that this is making a watertight piece of geometry. However, it's, it's making sure that it is, it's displacing in the same way that that geometry would have as well. So it's a pretty nice way of doing this, honestly. Like you don't have quite as many, weird little like folding geometry on top of itself. It does pinch a little bit in some of these places, and we'll play around with, fixing some of those things, but, or just smoothing this out a little bit. But, for the most part, it makes a pretty nice piece of geometry. So, let's do this. Let's see. Maybe we'll go down a little smaller here. I think for this one, we can have this a little bit higher. Let's see. Yep, 2.5. So you can change the way that these work, right? You can do them zero-centered, and it's just going to go in and out. Positive is just going to kind of bulge it out versus, let's see, something like that. Yeah, sure. Definitely don't want to go too crazy with it. So let's maybe do something like that. Yeah, cool. There we go. I don't know. That looks fine to me. We've got some rocks. The other nice thing we can do here is we can smooth this out, right? So we can take this VDB and we can SDF smooth. Let's grab this and we can smooth it out if we want to. The other thing we could do is we should be able to do this at other spots as well. Let's see here. We should be able to do it up here. Let's see if this works. So if we did this after our first noise and did something like, I don't know, a Gaussian, should smooth it out a little bit, and then we can add that in. Yep. So that might be a little bit better. We've got a little bit more smoothed corners here that we can work with. So you can see the difference here. We're basically smoothing off that initial geometry and, whatever. You can do a whole bunch of stuff with this basically and make some interesting looking rocks. You can add in different noise levels, all that kind of stuff. So it's a little bit more robust than dealing with the geometry because it kind of keeps recalculating that SDF and that gradient field so that the normals aren't going to be like going in, doing all these weird things. So, so that should be fine. Let's do a convert. Can do a convert VDB here. The other thing that we can do is we can use that. We can use this to, we'll use this obviously as a collision mesh. So what we could do here is convert it to a polygon. And this is maybe a little bit too coarse. So let's just go back up here and we'll make this, I don't know, 0.5. Let's try that. It'll take a second to calculate these, but it should be good. Hopefully it doesn't break anything. There we go. All right, so it's a little bit better. A little bit better from a resolution side on our geometry here, but kind of have a lot of points and primitives and stuff like that, so that won't be great for collision geometry. So what we could do, there's a million different ways you could obviously set this up. You could just straight up use this VDB here to help drive your geometry, but usually in a collision geometry, you have the geometry output and the VDB output. So let's just clean this up first. Let's just do a poly reduce and just get a few less polygons here. So we'll put this down. I'm just going to say manual here for a second. Turn this on. I always find that probably about that is a nice setting if you want to automatically have it do the, your tolerance. And we'll let that go for a second. Hopefully it shouldn't take too long. It's like a million polygons, but that's not too many. Great. It's pretty good. And then let's also just do, let's do that fast remesh. Worked pretty well before. Let's see how that works this time. Yeah. Okay. So let's do this a little smaller. Yeah, that's looking pretty nice. I guess somewhere in between there is probably fine. Yeah. So we've got quite a few less. We've cut it down by about probably 2/3, something like that. Still have all pretty good amount of detail there, but this should remesh. This should be able to be used a little bit quicker here. So let's do a collision source. We'll be using that in the flip solver. And let's just, so we're going to have null on this side here with our geometry. And then over here, we're going to have, say, geo. And that's going to be our VDB. Cool. We'll link this up to our voxel size in the solver in a second. So yeah, so that's pretty much how I set up this like little cliff here. I think it'll give us sort of an interesting waterfall because it's going to have these bumps and ridges and stuff like that, and that's going to help kind of create some visual interest as this water is coming over that edge. Again, like I said, you could make a flat edge, but that's not really going to be all that interesting. So better to make something that has a little bit more character. It's going to make a much more interesting solve, basically. So, okay, cool. So that is the cliff. Just make sure that's saved. And let's drop down a DOP network and do this. So put this here. Let's say this sim waterfall. And let's also do another geo here. And I'm just going to call this sim flip emitter. I like using like these prefixes for my geometries recently because if you haven't heard me explain that before, I like in the when you go in to say you do something like an object merge, right? I'd really like using this selector here to have your stuff kind of organized by that, right? So we can see here, this is geometry, this is sim base, you know, there's sim stuff. So it kind of keeps it a little bit more organized. I just like that. All right, so let's do a tube. We don't need to do anything too crazy here. We'll just grab a tube. We'll bring it up to the top here. We'll put it on the x-axis. I don't know, maybe a little bigger. I don't know. We can always play with that. Put some end caps on it. Doesn't really matter. Just adjust the height here. Yep, that's looking good. And this is obviously just going to emit some fluid into our scene. So let's just make sure it's low. We don't want it really to be adding too much vertical velocity here. And we'll move it back to the edge here just so it gives it a little bit of time to kind of come to some sort of velocity before it goes over the edge. We're also going to give this a little bit of velocity in the well, in this x-axis, right? No, it's a z-axis world space. So, cool. Let's do that. Let's do flip dop source. So that should be good. That'll start to give us our surface field here and some particles. Our particle separation will be driven by our DOP network as well. So we'll get to that in a second. I'm obviously not using any shelf tools or anything like that to do this. It's fairly easy to set up some of these flip elements now. There's not too much guesswork that you have to do. They kind of give you the things you need. So we'll add a velocity on here just to add the attribute. And what we're going to do is going to do this at negative, I think 2.5 was, I did a few different, I'll actually show you here. I set up a little top network, and if you want a little bit later, I can show you the top network and how that works. I don't know if you guys have any interest in that, but tops are really cool because you can make like little render farms for you. But for this one, I just did I honestly just wanted to, I like doing these like random little tests and stuff like that. But this is just the emit velocity for all the different versions here. So the coloring is goofy. That's just because I did something stupid by accident. But you can see here the difference in how that emission velocity changes the water coming over the top there. So I chose something that was in between these two right here, between this one and this one. That was just kind of it seemed like a good spot. You could obviously push it way more. Up to -5 is the last one down here. So if you can read those little tags, that's what each of those are. But I can show the top network I used. Cool. Yeah, I'll show that after we get a little bit further into this, just because it is a little bit of like a diversion in this, like once we get this a little bit more set up. But yeah, it certainly is super easy to set up from the most part. And if you have a decent number of like cores in your computer and stuff like that, it works really well. It flies. So like all of those took me like, I mean, I don't know how long specifically they took, but cool. Yeah. Okay. No problem. Sounds good, Tom. So, okay. So we've got our emitter here. That was where I got the velocity. We're going to adjust some stuff here, but what I'm going to do real quick is I'm just going to put down a split. The reason I want to do this is I want to add some velocity to these points. I want to kind of noise it up a little bit, but I don't want to have this volume here that I'm looking at. So what I'm going to do is just split that off, and I'm going to, I'll just grab both of these and add a merge here. So those are now coming back in, but instead I'm going to do just vector. Do it on this side, and now this should just be the points. Yep, sure enough it is. So what I'm going to do, just to make it a little easier to see, let's add a velocity attribute here. This will be a little bit easier to see. That doesn't seem like that's going in the right direction. It seems wrong. Hold on a second. Maybe I did something backwards from last time. Let me see here. Oh yeah, I definitely did. So the thing that's a little funny about the it might be a little hard to see those, but the trails here, the velocity trails, are obviously pointing in the direction like almost like a comet tail, whereas when you just see a vector itself, that's pointing in the direction that it's going. So like it's pointing forward. So I guess for some reason that was backwards. So I'm just gonna remove that or change that. So that should be right now. Okay. And those are really big. So let's just, I'm just going to adjust this a little bit here just to scale them down a little. So we've got, I don't know, 0.1 is fine. Great. Okay. So what I'm going to do is I'm going to add in here some noise to this. We've got amplitude, the range values I'm going to make sure are zero centered. So they're positive would only be adding it in one direction. So if you look at this, they're all going to be kind of pointing off to the left here, more or less, but we want it to be zero centered so that these can actually get noise in all different directions. And the higher this amplitude is going to go, the more it's going to push it in all different directions. And you'd have to go far enough with the zero centered noise to be able to go backwards here, which would be, yeah, you'd have to go quite a bit to get that noise to be going backwards, which we don't want. I just want to kind of add a little bit of directional noise here. So that should be interesting. Cool. And I'm going to make sure this is animated. We'll animate the noise. Let's see how quick that's moving. Let's turn on our little watch here. Yeah, that's probably too fast. Let's slow that down a little bit. Yeah, that's kind of cool. And let's see how big the element needs to be here. Well, obviously you can play with this. Maybe we'll do like 1.5. We want it to be relatively big. We don't want it to be like going crazy. Cool. All right, so we got some noise there. That looks great. We can turn this off. Go back to our merge here. And we'll just say null. Out. Okay, cool. So there's our emitter. Looking good. All right, so let's take this waterfall. I'm just going to hide that from the scene, the cliff. Let's just go back and actually just see the geometry from that. We don't need to be checking out that VDB. That's good. And let's go in here. All right, so let's drop down some of the stuff we need. We need a flip object. We need a flip solver. We need gravity. And we need a static object. And we need a source. So we need a volume source. Great. Okay, so these guys we can just wire together like so. Great. Those all go there. This will go into the first or the last port here, the sourcing. And actually here I'm just going to cut this because we'll take both of these, put them into a merge node, which is a collide relationship. The left affects the right, so this one is just affecting this one, so that's great. That's what we want. And cool. All right, so now we can start building this up. So first thing you'll see here is that this little like grid of particle down here, particles, we'll get rid of that. That's this initial thing from the SOP. So we don't need that. Let's actually make a little helper that can get us this geometry size so that this will fit nicely to this and we're not getting tons of extra area that we're going to be, solving inside of. So let's just go back up here. We'll go to our cliff and let's take the bounds. Let's see. We'll do the bounds over the. So this is a QLib node. It's nice because it has the bounding box info, so we can just directly grab it from there. So we don't have to do any expressions. We can just copy and then paste relative references. So here's the bounds over time. We don't really need to do it over time. It can just be on one frame. And let's change this here. Let's change the minimum size. The lower and upper padding. I'm just going to delete these channels because we're going to make a few different adjustments here. And I will probably just template this and look at that. There we go. Perfect. Okay, so let's take a look at this. So we can just add a little bit on the sides. We're really not going to need much there. So let's just do one for each of those to add a little bit of space there. Let's do one down just in case. I don't know. It won't really matter, but fine. Let's add a little bit up. We can maybe do like 2.5 just in case there's like some crazy splash that comes up. Back, we don't really need to add any. I think that should be fine. And let's do the, oh, in fact, you know what? Why don't we do this from the, nope, other one. Here, we'll just bring this back a little bit, maybe by 0.1. That'll just make sure that if anything kind of, there probably will be a little splash at the beginning that comes up this way. That'll just make sure it doesn't go over the edge. It'll kill it before it gets there. And let's take this upper padding and, I don't know, 10, just so that it's got some decent amount of room here, maybe even more. 12.5, I don't know. Sure, that should be fine. We can always adjust that if we want to. Actually, let's add a little more to these sides. I feel like that'll be good. Cool. All right, so that's going to be our domain that we're going to use, and we can just set this here, and we can just say something like that. Cool. So we can use that. We're going to use compute. So let's copy this parameter here. Just come back into our flip solver. We'll go to the volume motion and the box size, and we'll paste those relative references. So now we've got that size, and all we need to do is grab the center. And if we come back over here and paste that, that is now matched up. So that should be good. Okay, cool. So we've got that set up. Let's make sure these other things are working here. Let's grab our SOP path for this. This will be our flip emitter out, except that should be bringing that in. Oh, right. Right now it thinks it's sourcing smoke. You can just change this to source flip, and that's going to make that adjustment there. I don't love these spheres the way these work. So let's change that. That's in the flip object, guides, and we can go into particles and change it to particles. Cool. And this will visualize based on speed. So that's why this has changed some colors there. And that speed is coming from the velocity that we've put onto those particles. Okay, so volume source is working. We adjusted that in their flip object. Let's take our particle separation here. We'll copy that parameter. We'll come back over here and make sure that that is good. Particle separation, paste relative references. And then let's also do this. Let's do a jitter seed based on, I don't know, we'll do it based on time. And that'll just make sure that these points, as we watch them, oh, right, it's simming in the background already, which we don't want it to do. So I clicked the wrong thing, didn't I? Hide other objects. There we go. So this is basically just going to make this like a jittery field. If you don't do that, it instead will just be static, and you'll get these like weird streaks because the particles will be emitting from each of those particles every frame. So this gives it just a little bit of noise in there. I mean, you don't have to jitter it so high if you didn't want to. I don't know. Whatever. There's some settings you can play with in here. You can also just do it with a shell, I believe. Yep, there you go. So that is a shell that you could do it as well. So you can change it to be like that. So it's just a shell, but we want it to all be fluid. Great. All right, so that's set up. Let's go back in here. We're going to need to point to this SOP object here for our collider. So let's look at the cliff. We're going to say out geo there. That brings in the geometry. And let's take a look at one other part. We're going to go to collisions, and instead of ray intersect, we're going to do volume sample. We're going to say by size, and what we're going to do is set up the proxy volume here, which is going to be the out VDB. Great. So if we display the geometry here, turn that off, turn on our collision guide, we'll see that that is working. Oh, another thing, I always hate this. So this box, right, it actually sees this as a box. So I'm clicking on it and I'm rotating around this, which is really annoying. So if you want to stop that from happening all the time, you can just hide this right here, and that'll take the bounding box off of that, and now you can rotate around your geometry a little more intuitively. So let's just move this down so we got a little bit bigger viewport here. We don't really need to see what's going on there. Great. Okay, so we've got our volume here. Let's just copy this parameter. This will be our division size, and we can go. That looks funny. That's fine. Whatever. Not gonna be the end of the world. So let's bring that over here, and we will just paste the relative reference into here. So if we wanted to up the voxel size, we can do it right from our simulation. But this should be fine. Looks like it's got a decent amount of resolution. Could always tweak that if we wanted to, but for right now, that'll be fine. All right, so let's turn the collision guide back off. That actually is a really big resource use if you have that on. So don't keep that on while you're simming. It'll really slow everything down. I think it tries to recalculate that every frame, if I'm not mistaken. Even if this is off, I feel like that. Anyways, I've noticed that takes some time. I could be wrong, but regardless, it seems to be a little memory intensive or processor intensive, whatever. So anyways, okay. So we've got this set up. We've got a little waterfall going on here. In fact, we could probably bring that down a little bit. Let's bring it down. Bring it down. Just a little. Yep, cool. All right. So let's take a look at this, see what it's doing. And we'll go from there. So let's just hit play here. Should go pretty quick. Certainly not like a crazy sim. Resolution's pretty low too, so that's going to help us. Of course, as always, your mileage will vary based on processor and all that kind of stuff. So I'm doing this purely CPU right now. I'm not using OpenCL. I haven't really seen a huge benefit with my hardware setup to switch over to OpenCL for fluid sims. Not 100% sure why that is. I've never really dove too far into that. But yeah, anyways. So the thing that I really want to work on here is these like, oh shoot, I don't have my cache up high enough. Sorry, let me turn that up. Again, don't do that unless you've got a lot of RAM in your computer. You will use up all your RAM and then you'll be fighting it and your computer will be super angry at you. So, not that I have a lot of RAM, but I have 128, so you can, I mean, I would love to have 256. I'm sure tons of people have. Hey, how's it going? Welcome to the stream. Glad to have you. I would try to say your name, but I know I'll butcher it, so I'll just say hello there to the Houdini artist that's joined us tonight. Thanks for coming on. All right, so this is going, and what I was going to say is I want to kind of try to break up some of these like tendrils that are coming down here, right? There's these kind of just streams that happen here. And in a real waterfall that would be falling this distance, you'd have a ton of air resistance, you know, pushing back on these, right? So there's a couple things that, you know, you might want to bring into consideration for that, right? One of them is obviously the speed, right, that it's falling. That's number one. And then the second is like how deep those particles are into the fluid, right? Because it's not going to just push the whole fluid around. It's going to just move the kind of top layer of that surface and start to break that up. It's kind of similar to the way that we have disturbance that we put into pyro simulations and stuff like that. So I'm kind of thinking of it in that scenario where it's kind of taking that edge of the surface and breaking it up, right? So if you're not super familiar with flip fluids, the one thing to know is that we're working with both a particle-based simulation and a volume-based simulation, right? So we have the volume information from this, and that is giving us the information that we need to kind of calculate where that surface is, right? So when this is done, we'll go back and let it calculate that we'll show the surface. I'll just let it sim this whole thing out and we'll go from there. I might actually make this a little longer. I feel like we have a little bit extra over here that could benefit from, some more particles here. This is kind of just slow moving stuff that's getting pushed in here. I mean, it's fine. It's not the end of the world, but yeah. And so what you can see here too is like, see how these noise fields are moving through it. That's the noise that we added back on the emitter. So that's causing it to have some interesting movement here, and also causing these like kind of streams to kind of shuffle back and forth. So we are getting some nice, interesting behavior here. It's just that I think we could certainly get more interesting behavior. So what can we do? What can we do to affect this? So what I kind of was playing around with was the idea of using a pop VOP to be able to affect these particles, right? Because at their core, they're just particles, and there's part of this is that's being calculated on particles, and part of it that's being calculated on the volumes. So my thought was to basically go in and start to tweak the particle forces, right, to kind of push these things around. So let's turn this on first and just take a look at this surface, right? So we have a surface field as well that we can use. It's obviously rough. It's not like it's a perfect fluid surface, but we can see that there are some particles that are kind of outside of the surface, right? And there's some that are well inside of the surface. And so what we could do, what I was thinking actually today after I was playing around with this, is we could change the grid scale here, right? So this grid scale is going to affect how these volumes are built. So if we change this to like, I don't know, 1.5 maybe, go down a little bit, it's going to have to recalculate. But let's take a look at what that surface field looks like now. It shouldn't take that much more time to calculate. It'll be a little bit more. But if we look at that surface field now, it should be a little bit more detailed. So we could always turn this up a little bit and get a little bit better surface field representation. And that will allow us to be able to, be able to change how that breakup is happening to the fluid based on that surface. So now this is a little bit higher resolution fluid surface. It is going to take a little bit longer to calculate, right? Because we're dealing with a higher voxel count, right, that we're calculating. But we can see that we're getting a little bit better, a little bit better detail in this surface field. So, we can maybe split the difference and call it good for now. But let's bring in a pop VOP here and take a look at it. So this is our particle velocity node that we're going to be working on here. So let's bring in a pop VOP, right? We'll drop this here. And so now when we go inside of it, we're just inside of a VOP network, right? We're just dealing with stuff that you would with a point VOP, pretty much anything like that. We can get point positions, velocities, things like that from our particles. So what we can do is actually bring in that surface field and read it out in this network, right? It's a little bit tricky to do. It's not always the most straightforward, but I think it makes sense, and I think it's easy enough to do. So I was actually messing around with this for a while, and really it's a lot more simple than you might even think. So we have fields, right? So this is the DOP network geometry spreadsheet here, right? So it all changes everything around. So here's our flip object. Here's all of our fields. So as we go through this, we're going to see, all of our different fields here. We got a velocity field, the viscosity field, blah, blah, blah. All these are made. And if we look, we have a surface field right here, right? So what we can do is actually bring an input into this VOP network, right? On this inputs tab. And so I was trying to kind of figure out how I would get that into this network, right? Because you could do this also in a SOP solver as well. You could bring in these things and adjust it that way. But I figured this was a little bit more self-contained and made maybe a little bit more sense to not have to think about using a SOP solver to do this. So what we can do is we can actually bring in DOP data, right? And so that's going to be something from over here. And you always know that you're in DOPS because the way that this little pane here kind of changes a little bit, and you've got these pieces of data that are attached to objects, right? So we can kind of just think of it that way, is that we have this flip object and all this data is just attached to it, right? So there's geometry that's attached to it. That's going to be all our point data, right? We have a surface data here, but this is a little bit harder to visualize, right? We know that it's voxels, right? We know here's its voxel resolution. We know it had, what its division size is here, all that kind of stuff. So we know that it has attributes, but we can't really see those individual voxel values, right? It doesn't really visualize that. That'd be way too much. I mean, you could easily have, billions and trillions of voxels. It'd be kind of hard to visualize that in some sort of a, spreadsheet type thing. I don't think it would be very, very resource efficient. But anyways, what we're going to do then is bring this surface in, right? So I was looking at this and I was thinking, okay, well, step one, I tried this, right? So bring this over here. And I was like, okay, well, that's doing something, right? That's obviously doing something. But when I brought it in and started messing with stuff here, I got some errors, and it was like, no, that's not what you want to do. So I was like, okay, that's fun. Not great. So the actual end answer to this is a lot easier than even this, right? Because this is all saying flip waterfall, blah, blah, blah. What we actually need to do is, well, what I should have done is looked at the help card here. If we pull this up, I think it spells it out pretty straightforward in here. So let me take a look. And it should be, let's see, data inputs. Here we go. Under DOP data, this is what we need to look for. And so really what it says here is specified as an object/data. For example, pyro1/vel. Oh, okay. So it's not this huge long thing that we need to write out. Literally all we need to do is do the object and then the data that we want to attach to it, right? So instead of trying to worry about like, oh, this is like a surface field and like, trying to think that this is so complicated, literally all we need to do is just say flip object 1 and we want the surface field. Boom, that's done. So now our second input inside of here, just like if you were to have a multi-input point VOP or volume VOP or whatever, any type of VOP in the SOP context, we can now use this, op input 2 or anything that says second context input to be able to start sampling from, right? So if we do a volume sample, we can now start sampling that. Because this, we know that's an SDF because it's a surface, right? Yeah, it's a scalar field here. I think this actually, the color of it, yeah, this would be a vector field. So the surface is a scalar field. So it's not a vector field. So let's say here we're going to go second input. That'll be getting that. And primitive number, sure, it's primitive number 0. So it's the first volume that's coming in. And then we just need to do a sample position, which is just going to be our point positions. So we're going to use these point positions to sample where they are in the surface field. And I'm not 100% sure actually, now that I'm thinking of it, what the what's the word? How many band voxels there are on this SDF? That's actually really interesting. I'm not sure how many they would be. I don't know if there's a way for me to figure that out. Anyways, just thinking. But we can start without knowing that. We don't need to know that. This is something that just popped into my head there. So anyways, so we've got this volume sample file here, right? So let's do a fit range, and let's just assume that we're going to be getting -1 to 1, right? Because we know that 0 is the surface, so we're going either side of that. So we'll just call it good for that. And let's take this and we'll put it into a ramp. If I can type ramp with it. If I can type sometime, ramp parameter, there we go. We're going to bring this in from here. The reason I put this fit is because I want -1 to map to 0 and +1 to map to +1, because the ramp is looking for a 0 to 1 value. So let's just put this into CD to visualize it for now. We're going to work with this a little bit differently in a second. But now let me turn off the surface, and I'm going to turn off this visualization. We don't need that. All right, let's pull this down. now what we should hopefully be getting here is a visualization on where that is in the surface. And the reason it's looking like garbage is because we have it set to black and white. So let's do something, I don't know. Just do infrared. So green will be the middle, purple is inside, red is outside. And we'll just watch this. So there we go. Green is mainly the surface. Great. And then as it starts to shift, we're not really seeing too much there. So I think what we're working with right now is that we've made that range too big. I can see it changing just a little bit, but it's kind of just only going towards blue or a little bit maybe towards yellow. So we can tweak this. And actually the really nice thing about this is that we can tweak this while it's in, kind of in a state like this. So let's grab the pop VOP here. We can go inside of it. We can still see it here, which is nice. And let's just adjust this. Let's do like negative 0.1 and 0.1. Now we're seeing something. So we can see that when it's deep inside of that, or fully inside of the field, we're getting it at this this like dark purple here. So we can maybe something like that'll be better. Yeah. So there we go. We can start to see how to adjust this. And the other thing we could do too is say the source minimum, like where we want it to affect the least, is going to be 0.25 inside, and then the maximum could be at 0, let's just say. So anything past the surface is going to be affected, right? Or we could adjust this to be 0.1, so it's just a little bit past the surface, it's going to start getting affected. There's all sorts of different ways that you can kind of make this work, right? You can obviously see that this is going to be well inside of that and not be on the surface, right? Because it's inside of this big flow of fluid that's up here, right? And then as it comes down here, we're starting to see more yellows, oranges, and reds because it's starting to break up already. And we want to kind of help that along. So yeah, we can play around with this however we'd like. We can make this a little bit stronger. We can make it weaker, whatever we might want to do here. So let's just leave it like that, right? Okay, so we're starting to get somewhere. We have a kind of a a range now that we're starting to build up, a 0 to 1 range that we can use to start adjusting the forces on this fluid. But the one thing we don't want this to do is have this noise up at the top here and be affecting that, right? We don't want it to be doing that at all, because that's really not the point. Like, we don't want it to affect the top part. We only want to affect it once it's falling. So let's think about what we can do here. So let's take the velocity and let's get the speed from it. And we'll just make a length, grab the velocity here. And when we do the length of the velocity, that gives us a float that is the speed. And we can bring that, we can grab another fit range here, put this value in. Now we want to adjust this a little bit because our source minimum and maximum are going to be based on the speed. We still want the destination min and max to be 0 and 1 because we want to keep it in that range. But let's change the source. So what I'm thinking is we want it to be influenced when it's in free fall, right? So, and be more and more influenced as it goes faster and faster. Maybe to a point. We don't maybe want it to stop at some point. But we know that gravity is 10 meters per second. And so maybe if we have it set to be somewhere around 9, and maybe the maximum is when it gets up to 20. I don't know. I'm just kind of making some guesses here, educated guesses based on this. Let's do that. And then what we can do is we can multiply these together, because that will make sure that places where one of them is 0, it's not going to be influenced at all. So now we can start to see that we're getting that down here. And so as we adjust this source minimum, which these are obviously a little bit, what's the word? They're a little bit too far to the right here, but so maybe we want it back a little bit so it starts affecting it up here. And this could probably be a little lower. Something like that. Cool. And let's just play this and see how it looks from the beginning, just to make sure there's not anything that's like going on crazy up at the top here, because we don't want that to be really happening. Yeah, there's a little bit on the front edge, but I think that's fine. I don't think there's any issue there. Yeah, that seems good. Cool. Okay, so we've got some stuff going on here, but we need to start adding some forces into our simulation, right? So let's let's just try something really straightforward before we get anything too crazy. Let's just try adding like a force that's like to the right or something, just so we see it, you know, and know what's happening to these particles, right? So let's see here. Let's do a let's just do a parameter, and this will be available up from the node above when we come up out of here. So let's just do a vector, and we'll call this I don't know, force direction, something like that. Not Dorse. Force direction. And we'll just multiply this. So we'll take this vector, multiply it by this 0 to 1 float, and then take that product over to here. And let's just set that to something decently high. So we have our ramp here, which should, oh, right, I didn't rename it. It doesn't really matter what it's called. It's just called ramp. Fine. I probably will delete that eventually, but here's our force direction. If you want to tweak these things, you can go into your edit parameter interface, make sure these look a little nicer by doing something here. We could take the, put in a separator there or something like that. Here. Maybe there. Just to make it look a little nicer. Sure. All right, so let's just do it, I don't know. Let's just go crazy. We'll just do something like 20 for right now and see what happens. I'd say it's working. We're getting something. And what we should see is that there's some of this stuff that's going to go more straight down, and there's others that's going to get blown a little bit more to the right. So it is happening fairly uniformly, which might go to say that we want to adjust a little bit how this is getting taken from the surface, right? So let's start to do a couple things here to make this a little easier to work with. So let's take this, and we're going to promote some of these parameters. So let's do the source minimum and source maximum. So if you middle click, you can promote these parameters. That's going to do the same thing that this parameter does, but they're kind of all just contained in this. So we'll call this surf min. Surface distance. I'm just going to copy that. Well, actually, I'll just call it minimum surface distance like that. And then this one will be maximum surface distance. And we'll call this surf max. And then down here, we can say promote both of these. And this one we'll call speed min. Oops. Figured it already said maximum there. So we'll call this speed max. Cool. All right, so now we have all these things in here, which is good. Could just do maybe a spacer here to give them something, some visual separation maybe. I don't know. Yeah, great. Cool. So we're starting to build up a little custom velocity kind of setup here. And so now we have these that we can just tweak from this position here. Also, since these are quite a bit too long, let's tweak those real quick just to make it a little easier to work with. So the minimum speed, let's see. First we know the, oh, you know what? Actually, we can do that much easier inside here because these should have flow ranges. Yep, for sure. Okay, so we're going to do this influence speed. I don't know. Maybe we'll do these to 25, something like that. Great. And then these we can do, we'll do them -1 to 1. I think that'll be fine. Great. That should feel a little bit better. Yep. All right. So let's just tweak this a little bit. Let's let this play out and we'll see what specifically, you know, where these, actually, you know what I'm going to do too? I'm going to change this to be 0. We don't want to add any force there. We'll just let this fall. And we'll give it a few seconds here to kind of develop well. In fact, I'll just jump it forward to like 72, let it sim up to there. Great. So I think what I want to do is have there be a little bit more surface influence. Like the speed I'm good with. Like I think the speed part of it is doing a good job because as it's falling, it's becoming more influence. We can see that pretty obvious. But I feel like the surface distance is what's kind of lacking here. So let's just tweak that a little bit and see where that gets us. Oh. Okay, that seems good. The minimum surface distance. So maybe that'll be better. Let's see here. Let's go back. I just want to put this back to where it was and see where that looks like. 0.05 and -2. So yeah, we can think of as this is the region right here where it's working. It's working anywhere above this and below this. So all right, let's do this. 1, 2, 5. This one. We'll just make this a little bit more extreme. I think that'll be better because it has to be further away for it to really get moved over. And I think that'll be pretty good. I don't know. Let's try whatever. All right, so let's do this. Let's do -20 here. Let's see what happens. Just want to get a little bit better visual here of what's... You can see as those little particles kind of blow out there up at the top. They definitely get a little blown away. Now, obviously, we won't be doing this exact situation here. We're going to add some noise in to make this look a little bit better. But But yeah, I think this is doing a little bit more of what I was hoping it would do, where these streams are staying a bit more together, and other things are kind of blowing away a little bit more. Let's do this one more time. Let's do this. Bring that up a little bit more and see what that gets us. Yeah, that's doing more what I was hoping it would do. So in this case, we're getting some that's almost falling straight, which is good, and the little pieces are getting blown away. So that's kind of the important part here, I guess, is to kind of balance those attributes, right? Is to be able to get the surface, like the center of it sticking, and the outside part be the part that blows away, right? That gets affected by the wind, right? So cool. That's looking good. The other thing we could do too is instead of that, we could do it -20 this direction up. And this is going to have like a wind force that'd be going straight up, right? So that'll be a little bit interesting looking as well. And in fact, it'll go against gravity. So it's going to fly up in the air. So I don't know if it'll stay quite, because it's going to be slowing it down, right? So it's like almost like a drag force kind of, but a little bit weird. I don't know. We'll see how this actually works, but let's see what that looks like from the side. So from the front, it doesn't look like a whole lot. Yeah, it's starting to do a little something there. In fact, I might have been a little overzealous with this. So let's try this instead. Something like this. Maybe with it blowing to the side, it was much more obvious than blowing straight ahead or blowing up, right? Push this up a little further. I wonder if that's just not enough to fight gravity, because it is technically a force, not a velocity. So that could be why it's not as obvious. Well, we can see where this is affecting, right? We can see where these fluids are definitely breaking up. But all right. Well, let's move to actually working on the noise with this, and then we can start to see how this will kind of affect it from there. So let's go in here. So instead of this force direction, let's get some noise going on here. So let's do a turbulent noise. And we can get that based off the position. We'll have it offsetting based on time. And the amplitude, we can just, we just run it at 1, and then we can put a post multiply kind of attribute at the end of it. So there's our turbulent noise. Let's pipe this into here. Now, that's just 1D noise. Let's do 3D noise, and let's do this as simplex. And what I can do here is I'm just going to do, I'm going to bind export this. and give this a name, just something like a force, something like that, just so it shows up early in my geometry spreadsheet if I want to look for it. And I'm going to unconnect this ramp parameter. And instead of doing that now, I think what I'll do is bind this to its own attribute as well. So I'll do bind export just so we can visualize this differently. And I'll just call this something like weight. The reason I'm not calling this force either is because I believe it's exporting out of here as force, and that could get it goofed up. So I'm just calling it something a little different. Cool. All right, so we've got our weight and our force coming out of there. We're not coloring it anymore. We could just go back to our standard visualization type. That's fine. Either way. So what I can do is I'm going to come in here. I'm going to add a color. Let's call this weight. I'm going to say ramped attribute. We're going to go for this is a point, and it is weight. We're just going to do 0 and 1 as minimum maximum. Let's see if that visualizes it or not. Probably need to turn it on, huh? Ooh, yeah, I don't want those. Don't want those velocities anymore. Let's just do something pretty obvious. Infrared. Oh, 2 G's. That ain't gonna do it. Well, we are exporting those weight attributes there. And there are force attributes as well. I don't know why that's not showing up. It's a little odd. Well, I guess we could just visualize it here. It's very strange. Let's do weight. Yeah, there we go. That's working. And then what we could also do is, let's hope this will work, because I think it will. So maybe the color didn't want to work, but we'll use the marker. We'll just call this force. Do a vector. Oops, maybe pick an interesting color here. I don't know, pink, sure. And we can turn this off for right now. And we will say point, and we'll call this a force. There we go. Cool. And there we can see, ooh, that's kind of tough to look at. Let's pick a better color. How about that? Sure. Blue. All right, so we can see all of our different force vectors that'll be getting acted on here. And what we can go with from here, we can look at where that's being applied by moving it over to this side, right? So now we can see specifically where those force vectors are going. And what we could do here is we could do a multiply as well right here. Promote that parameter. It's going to set it all to 0 because it's set at 0 right now. And let's just say this will be force global. I don't know how big we'll make this. Maybe 250, just for kicks. Cool. And the default will be 1. There we go. So now we've got this global multiplier here, so we can do 25 if we want to, and we can see all of those vectors, and there's not going to be any up here because there's no forces being applied up there, but they will be down here. And we could also promote all of these turbulent noise attributes. You know, the frequency will adjust to make it bigger. As the frequency goes down, the kind of scale of it is going to go up. So we might want this to be a little higher frequency. Maybe it's like, if its default is 1, maybe we'll try 2, something like that. The amplitude we can just leave at 1. Could bring the roughness down a little bit, maybe. I don't know. Just guessing at this point. But that'll help break it up a little bit. Or it should help it break up. We'll see. See what it does. So now we're going to have all of these, you know, vectors moving on it. So let's see what happens here. I'm going to turn the visualization back on to speed. Oh, interesting. Well, we'll do the whitewater one. See how this looks. Well, I guess what we should do first, before we go any further, let's get a shot of this with it looking normal. Yeah, like that. Cool. All right, I'm going to do a flipbook of this. So we can have it and take a look at it. So let's flipbook. The old startup time. There we go. Oh, and actually what I meant to do was turn this off first. So I want to get a regular flipbook of this looking normal first. Wait, why is that white? I see, because of the visualization attribute. Weird. Nope. There we go. All right, so we'll do this like that. Or maybe we'll just let it. Let's see. Don't want it to go so white. Let's do it to 20. Cool. All right, go again. All right, well, hopefully everybody's getting some interesting information from this. You know, you can see how you can tweak and adjust things inside of DOPS with using things like a VOP network. So I think that's kind of a cool thing to be able to, see in practice. Just observing how this is looking here. Let's see. I think we'll make this a little shorter. Just make this 144. Please tell me that's not going to have to resim. It will. Of course it'll have to resim. Well, yeah, of course. Let me let this go, and we'll take a look at that. So what the pop VOP is doing is it's looking at particles, right? And so it's working very similarly to how a point VOP would work in in SOPs, in a SOP context. So what it's doing is, at least right now, the way I've got this operating is it's working on two different things. It's calculating the speed that this fluid is falling, and it's putting a weight attribute, or it's kind of saving that as like a value from 0 to 1. We're outputting a 0 to 1 value based on a speed range that we've come up with. And also we're using the surface field to figure out how deep the particles are into the fluid surface, or the calculated fluid surface, from the solver, from the flip solver. So we're using both of those in conjunction to make a weight out of both of those, and then we're going to drive some forces basically to push this fluid around as it's falling, basically, so that it's actually getting some, air kind of looking stuff breaking it up as it's coming down. So it's not so much like a streak, but hopefully it's going to break up a little bit as it comes down, and falls faster and faster. In this case, you can see the speed based on the visualization. So as it gets whiter, it's going faster. Right now you can see here the visualization range is set from 0 to 20. So the way that you get the surface field into here is by going to inputs, changing the second input, or whatever input you might want to use, to DOP data, and then taking the object and then the data that you want to work on, which in a DOP network are all of these. These are all like pieces of data basically that are attached to this flip object 1. So that's how we're working on the pop VOP. So, and the reason we're using that is because in our flip solver, it can either have stuff that deals with particles or with volume. And so we're putting stuff into the particle input here at the beginning. So this first render is the without the particle VOP, or the pop VOP. And let's just really drive this far, just so we can see it, really do something, and then we can dial it back. But hopefully this should give us a good change. So, all right, so we've got that there. I'm going to turn this off so we don't accidentally move the camera around. Let's hit this up here, and we'll add another one into that flip book and see what this looks like. So now we should be getting these random velocities, or random forces, added to these particles as they're, at the surface of the fluid, and the faster they go. So the faster they go, the more they should get kind of broken up and pushed around, and the further they are from the surface, the calculated surface in the solver, the more that should affect them as well. So let's see, we'll let this go for a little bit, and then we'll take a look at how it looks comparatively. Bring up the sequence list here. Well, yeah, the interesting thing, first of all, is that you can see that this is like much wider than the other one was, which is kind of interesting. I wasn't really expecting that. But let's see here. kind of widening out these elements, kind of like pushing them all out in some ways. It's creating a little bit noisier situation here. So let's take a look at that. So yeah, it's like catching some of these little edges here and kind of moving them around as they hit like some velocities and things like that. So it's not even the most obvious from the front. So let's do one more. Let's take a look at it from the side and see if that's any better to get a sense for how this is. Yeah, honestly, I didn't either. I knew it was probably possible, but I just wasn't sure what to do. But yeah, it definitely works. I mean, you can get it in there. So yeah, Jack, I am in the same boat. I did not realize that was truly a thing. So let's see here. How can we do this a little bit nicer? Let's look at that. Cool. All right, let's take a look at this one then. Okay, there's that. You can actually see where the bounds of our sim box are right there. Let's try that, and then let us, let's turn this off. Well, let's see what the difference looks like from the side. And truly, this there could be one interesting kind of little X factor in this, is that the force might be harder to Yeah, I mean, I would think that you could have it work in other systems. I don't know. I can't say that I'm pyro with divergence. I mean, yeah, I could see that. Like if you're doing an explosion, yeah, I think I would agree with that. I mean, you can definitely art direct pyro. That's 100% true. You can do that. I've done some stuff with it where I've literally had it like spiraling around and been able to make it look the way that I want it to. So you can definitely art direct pyro. That's 100% possible. Explosions, it's easier to do that with the sourcing, I think. Now I have to substantiate. I don't know what that means. I'm not sure what you mean by now I have to substantiate. My vocabulary is apparently not big enough for that. Let's see here. Let's see what the difference looks like here. Because I might be, I'm not really happy with how that's, I feel like it should have done something a little bit more. Interesting. Okay, let's try something different then. I don't like how that worked. I feel like this was doing something a little different for me yesterday. Let's go crazy with this and just see what it does. Because I feel this doesn't do anything. I disconnected that. But let's try this and just make sure I'm not losing my mind here. You need to back up your claim. Yeah, I mean, it's definitely possible to art direct pyro. Now, I was doing it with forces and things like that. And that worked pretty well. But I can't say doing something like this would work with pyro. I mean, I guess you could do it with a volume. No, I mean, this is different. This is a pop fop, so this isn't really going to do that. You'd need something. Maybe you could do it with a SOP solver or something like that, but I just want to see what's going on here. See if this actually breaks up nicely or if it's doing something dumb. All right. Not cam 2. Let's go to cam 1 and see what that looks like. Yeah. Yeah, it's definitely like it's cool to like realize that you can bring in these fields into a DOP network like that. Like that's definitely a cool thing to be able to kind of play around with. Okay, maybe this is doing something. I'm very confused about this right now because I felt like I had something going a little bit better the other day when I was playing with this. I mean, it's definitely working. It's doing something, but I'm not sure I love what it's doing. Just going to pop this up to the top, I think. Yep. Wait, what? What did I just do? Now I don't know which one's which. Yeah. Well, you can definitely see that it's thickening it up here. So that's first of all working and doing some stuff. Yeah, I mean it's definitely adjusting it. Just maybe not as much as I would like for it to. I kind of want to play around with the velocity, but first, before I do that, I'm going to show you guys the DOP network that I had set up. So this is my sim that I was playing with the other day. It's basically the same thing. I had a SOP solver in there because I was playing around with that a little bit. But the more interesting thing is here. Let's take a look at this top net. Pull this up. We don't really need that. So I think if I just cook this, it will all just fill in. I don't think it's going to do anything. Yep. Okay. So here's my top network that I was working with. So what I did was I wanted to wedge out those different variables, right? I wanted to wedge out those different initial velocities. And so what I did is I started off with a wedge and had it do 10 with a range from 0 to -5. Whatever reason it was negative. I don't know why that happened, but maybe I rotated it or did something weird. Anyways, so here's all my different work items. If I middle click on them, you can see that they have different emit values right here, emit velocities. So this one will go up to -5 and this one will start at 0. So these run the whole gamut here. And if you're not familiar with tops, the way that this works is that I can kind of see how these flow, right? So I can see where these are all. Now that one's not super interesting because it's 240 frames, right? And so it's kind of selecting a whole group of them. But if we select the next one, and let's see, move over here, you can see that some of these are selected and some of them are not. And these selected ones are the work items that relate to this first one. So each of these next ones down here in this get sim, what this is doing is finding this in here, sim export. I did a little flip sim cache here. So I'm getting the flip sim from the DOP. And then here I'm saving it in a file cache. And this is all being written to disk and everything. But what it's doing is it is using the name of it here. And what I had originally set was this version was getting driven by the wedge number, I believe. So if I do like this, and then do at wedge num, I think is what it is. We'll look at it. What you can do is you can have these. Yeah, that seems to be right. It's getting a 1, so that. What's the problem here, guys? I don't know what it's doing here. It's like happy with that, but it's also not happy with that. Okay, maybe it's okay. Yeah, it's not able to. It's not able to figure that out. So this is saying, I'm sorry, it's not wedge. Oh no, wedge number. Yeah, there it is. Wedge index also works. So let's see here. Is it PDG wedge index? Well, anyways, I was using this to it was driving it from that wedge number. I don't know why it's not right now, but whatever. At wedge index. Oh, doesn't need the backticks. Sorry. That's probably what it is. I would have a feeling that that's the answer. Yep. I bet you that's the answer. And yeah, there we go. And what I did was I did wedge index plus 1 because there is no version 0 here. So there we go. Great. So anyways, those were my versions. And so this was saving a different SIM cache, and I was putting them into these folders based on their versions. Anyway, sorry about that. Wish I could get that to go away, but whatever. All right, so top network. So we did that. So it gets the SIM, and it pulls it from that SIM cache. So it runs all of these work items based on that. And then here we come down to this next ROP fetch. And what this is doing is running a ROP, which is an OpenGL, and that's inside of here. And there's just an OpenGL ROP here with the output name. And I've got this with like wedge number, stuff like that, so that it's saving each of them with like a different index based on which wedge they're related to. And so it's just basically rendering the scene out. And that gets all those work items. Then this next one is a text overlay. And I have this set to be in a frames per batch of 48, because what sometimes will happen in tops is you will have, it'll start, each of your work items is its own like instance of Houdini basically. And so it starts up all these instances, right? And so in this case, or in most cases, the scheduler will look and say, okay, the number of work items that we can work at the same time is equal to a quarter of the CPU count. And that's the threads in your CPU. So I have a 32 core, 64 thread. So that means a quarter of 64 is 16. And so it can run 16 of them at the same time. You can customize this and set it to whatever you want, but that's what it is on my system. And so what happens here is that it tries to start up 16 instances of Houdini and does one for each frame. And then it goes on to the next set of them, and then it starts up 16 for the next 16. And so that, as it kind of leapfrogs and goes through, it keeps starting and stopping Houdini. And that's not always the most efficient. In some cases, it's totally fine because it's literally like reading and writing and doing it super quick and whatever. But in this case, what we wanted to do is to say how many frames per batch. So what I did is I was like, let's do like 2 seconds of it in each batch. So when each 48 frames so like when frames 1 right here, which you can see is frame 1 to like frame 33. Oops. What is this? Yeah, go away. Thank you. Yeah, I don't need you to be locked. Like, so this is 71. So it's somewhere in there. There's a frame number, right, that it's going to go to. Gosh, that's really annoying. I heard somebody turned these off, and I should probably do that. Anyways, somebody mentioned that the other day of turning those off. So it'll go through each of those 48 with one instance of Houdini and doesn't have to start it up 48 times. So you get quite a speed improvement on stuff like this, like compositing or even OpenGL. I believe I had that set. I had that set to 24 just so that it would do it in shorter little bursts, because I knew this sim was going to go a little bit slower probably than this OpenGL would down here. And since this is a sim, the way that I did that was all frames in one batch, because I knew that it couldn't wouldn't want to start and stop. So that was an important thing to check when you're doing a simulation, is doing all the frames in one batch. So that means that the whole 240 is going to be one simulation. So this can have 10 running on at the same time, basically. 10 is the most, because it has 10 instances here that it's going to be going through. So there'll be 10 simulations worth. Thus 2400, because I had 240 frames. Anyways, so we get to the text overlay, do all that, saves those little images with the overlaid text on it, uses a COPS network. Yep. And then here, once we're done with all 2400 there, we need to sort them by what frame number they are. And so this partition by frame goes through and looks at the frame number and partitions each of them. So if I double click on this, yep, it'll bring up the work item, and we can kind of identify what's going on a little bit better here. So what we're going to be looking at are the partitioned items, which are the things that are coming from upstream. And then the output of this is going to be these right here. So we have, these are what's going to be spit out for each of these work items. So now we have wedge 0 through 9 and frame 1 of that. So now these are all sorted. So it's 10 frames that are identified by one work item. The reason that's going to be really nice is because that's going to feed into this ImageMagick top node. And what this does is runs a command line script called ImageMagick, which you have to download and install separately, which kind of stinks, but there's instructions on the Houdini help file that tells you how to do it. So it's really pretty simple, but you do have to install it. Free, doesn't cost anything. So this will do that montage that you saw earlier with all the images lined up next to each other. And what I'm doing here is I'm giving it the ID of the PDG index, so that each of these are getting their index number for the file, right? So this one's going to have an index of 1 in the file name. That's just something that gets kind of processed on each of these nodes. So we're going to have 240 of this, and they'll just be saved with that index. There's other things you can do here with compositing and things like that, but the montage is probably the cleanest way of doing this. So this will set all of those montaged frames up individually that were all kind of side by side. At the end of this, you do a wait for all, just because we want to make sure that all of these montaged images are ready to go. Clicking that, we'll click all of them, which kind of was silly. But so if we click this, you'll see that this is going to combine all of these images here into one work item. It'll feed it into this FFmpeg encode video top node. And this is basically just going to save MPEG out. One of the little tricky things here is the file, the frame list file. You want this to be on this, it has to be on the same drive as your directory is for your project, I want to say. And so I just set it to be a HIP file right next to in my HIP variable. And if we look at that here, it's this right here, which is just a text document. And this is just literally for it to know what frames it's looking for. So that makes an MPEG, and then you export, or then it exports it for you. So this whole network here, all of these steps, if you come down to this montage video, if I deleted all this from disk and right click down here and said cook node, it will run all of these processes automatically, stitch them all together, put the text on top of it, and make an MP4. And the other thing too, I should mention, this text overlay is right here. So really all I did was told it to say emit velocity, gave it a semicolon, and then I put in here the emit velocity attribute, which is the wedge. So this wedge right here is creating emit velocity, right? This emit vel attribute. And I can reference that anywhere else in Houdini with just saying @emitvel. And so in this text overlay, I did that right there. And based on which one I've selected, so like if I select this one here, which is -3.88, whatever, I go to this text overlay. If I middle click on this, you'll see right here, 38889. And that's what's going to be overwritten on that wedge specifically. So that's the top network that I used to make all of those files. And I literally just ran this overnight. I'm not even sure how long it took from start to finish. But let me see. I can probably see how long it took. So where did this? So the last step was the video, but I actually re-rendered that the next day. But so here's all my geometry files. Nope, sorry. Sim files is what I want to look for. So for example, the version 1 through version 10 looks like it ran at about 47 minutes for the 10 sims. And looks like the images were done. Oh, I think I redid those as well. But anyways, the OpenGL renders were done by 12. The overlays were done the next day. That one I had an issue with the overlays that I had to redo. But you can see it goes pretty quick to do 10 simulations, full flip fluid simulations and get all that stuff done. So it's a pretty nice process. And if you run into any issues with it and you delete the files from disk, and rerun them, it'll start, as you can see here, this is all populated. It'll start from wherever it's found files, basically. So if it knows that there's these overlay files, but, oh, we need to do the montage and the MPEG, it'll redo those if those have been deleted. So it's a pretty robust system, works really nice. And it doesn't just work on Houdini stuff. You can do stuff like file copies and patterns and compress and decompress them. It's like you can unzip files and all sorts of crazy stuff. You can download files from the internet, I think. Yeah, I think that's what this is. Yeah, you can download a file right from the URL and use it like that. So you could download it, unzip it and stuff like that. So pretty crazy stuff that you can do in Tops. It's not just Houdini things. So, I mean, there's also a whole bunch of cool stuff that links into Deadline or Tractor if you want to use those types of things, shot grid, all sorts of really cool stuff in here. So a bunch of Python stuff that you can do in here. You can even notify. I think you can. I'm not sure how this works. I'm not sure what that specifically says, but you can do. You can send an email, I think, when it's done. Which is kind of funny. So you can do all sorts of cool stuff in here. And hopefully that's interesting at least to see. All right. Well, let's do maybe one more thing here before we're kind of done for the evening here. It's getting a little late, but let's try one more thing. Instead of doing it this way, maybe what I'll do is I'll grab the velocity. So we have this, we know that this is how much we want these things to be affected. Let's see if we can grab the velocity here and should we probably add it. Yep. We'll do an add node and we'll add the turbulent noise into it, and then we'll do a mix here, and we'll take this weight that we've set up here, set that as the bias. So a weight of 0 will take the original, which is we can just set as velocity here. So that's the velocity coming in. And then here's the summed velocity there, and here's the blend of it. The other thing we could probably do is take this multiply here. Oh, that's weird. That's really strange. It took the promoted parameter out of that. That's interesting. Well, let's just do this instead. We'll just promote this amplitude. Sure, amplitude. Great. There's an amplitude at the bottom. Cool. So let's try this, because what this is going to do instead is I gotta put this into somewhere, to V, and I'll get rid of this from force. So instead, let's try this. So this bias is going to blend between these two. And so the more weight we give to it, the more it's going to add the noise into the velocity. And I think that maybe should do it. Something. We'll see. And we'll crank the noise up a little bit. Well, let's just leave it at 1. We'll see. We'll see what it does from the start. It might just totally freak out. It might not work at all. But let's see. Actually, you know what? I'm going to take this force here, and I'm going to output this right here, this blended, into that so we can see it. I just want to see what it's actually doing. Let's take a look at that. Oh. Oh, right, because it's taking the velocity. Well, let's just turn the velocity vectors on, and we can at least use that to see what's going on here. All right, let's just get crazy with this and just see what 10 will do. It's probably going to be way too insane, but we'll see. Oh, it's definitely breaking it up more, I think. All right. Oh, yeah. Okay. Maybe that was the smarter play from the beginning. It's definitely getting a wider base down here that I kind of like versus this. Let's just click that, and let's see. Yeah, it's definitely something interesting. Not sure exactly what's going on there, but let's see here. Yeah. Oh, yeah. All right. Well, that's definitely working. I like that a lot. We're getting less of those tendrily. So here, let's take a look at this here. So if this is, I don't know if we can, is this the right one now? Let's see. Yep. There we go. You can definitely see it happening. So it's breaking up these edges. Maybe it's too much. I don't know, but we'll see. But it's definitely giving these a much rougher look than this. So here you can see this really tight stream going on here. And now this is breaking it up and spreading it out. And in fact, I think if we look here, no, where was it? There's a spot where, oh yeah, right here. This is this like crazy line. If we look at this, it's the same in some ways, but it's broken up. So this is definitely how we want to do this. So I guess the force thing was maybe a little too much. So yeah, that's looking a little better. Cool. Just move around it and take a look at it here a little bit. In fact, what I'm going to do is I think I'm going to turn this to none. No, I want it to just be black. Let's do this. Let's do a geometry node. Get these guys out of here. And we'll use this to get our geometry in. And so if we do DOP.io, I want to say, yep. Kind of a nice new thing with the DOP.io. They have, they add this file cache on here. And we can choose to do something like a flip fluid. And then we can grab our network, which is sim flip waterfall. And the DOP node we're going to get is flip object 1. There we go. And there is our waterfall doing its thing. And obviously you're going to get nicer results if you, if you turn up the resolution, all that kind of stuff. I'm running it relatively low just so we can have quick results and things like that. But you're going to get better look based on, based on how, based on how you, like how dense you get your particle point count. Sorry, I was just thinking something else. I'm just noticing one thing here that I'm not like super thrilled about. It's like right here. It's like looking a little too, like linear, the way it's like kicking in. And so what you could actually do to fix that would be, at least I think you could, would be taking this. I can get rid of that. That doesn't need to be there anymore. And what you could do is you could take your weight here that we're creating, right? Because this is going right into our weight. Don't need that anymore. And this attribute right here, what we could do is we could do a ramp. Oops. I'll just do a parameter, ramp parameter. I'll stick this in here. And if instead of doing an RGB color ramp, we do a spline ramp, and we go here and just say like, call this weight ramp and weight influence ramp. Did I type weight ramp? Weight ramp. And what we could do here is we could have it slowly build up, right? So we could do something like this, right? And let's just select these all, change them to, I don't know, like a B-spline or something like that, right? And so we could have it, more slowly ramp into that and then get heavier as thus, so that it's not so like just linear the way that it's kind of coming out. So if we play through this a little bit, and watch the way this is like breaking up here. now I think we'll see that this is a little bit more natural looking here. And the values might be too high. It's a thing to play around with as well. But it's going to be a little bit less of this like straight line coming out and more of a, a feathering in of that value. And you might need to tweak that, this is all very much trying to direct something that's very dynamic and changing, kind of like Jack had said, can be kind of hard to do, but with this, you kind of have it slowly ramp in. So it might not be as obvious at first, and then it'll kind of break in a little bit more as it's coming down. So, and as that weight value is kind of going higher and higher, it's going to push that out more and more and become a stronger effect. So something to keep in mind there. But anyways, this is how you would get it in here. This is bringing in your surface, your velocity fields, and your geometry. And you should do a fluid compress. This is the new setup, but you can just use it with one. Someone just texted me, "I'll ramp you down." So one of my friends is clearly watching me right now, which is very creepy to get a text that says, "I'll ramp you down." But anyways, so what this will do is it's going to compress your fluid into VDB, packed VDBs, I believe. Yes. And so it's going to put it into packed geometries. And this is a way to save it to disk much more effectively. It takes a lot less storage. And this has the three ports that you would use in the SOP fluids as well. But in this case, you can use it for just one and it'll compress it that way as well. So, oh, yeah. If you wanted to slow it down. No, I don't think you'd have much to do at this point. Let's just see here. What is it? Retime? I think they've really... I always... when I was working at my previous job, I always... whenever there'd be something that a client would ask, I would always like get a comment from like my... have some conversation with our creative director and be like, oh, what is this next project going to be? Oh, it's going to be fluids and smokes and all these different things. Yeah, cool. Okay, sounds good. And then at the end, he'd be like, and we're going to do like all these speed ramps and do all these things like that. And it's always like, gosh, can't we just not do speed ramps for once? Like, I felt like every project had to have a speed ramp in it or something crazy like that. But I think this will work pretty well with this. Let's just check this out though. Let's go to the end here. Make sure this is simmed all the way to the end. Is it? What's going on here? Yep. There we go. Okay. Sim to the end. Great. Yeah, so let's take a look at this here. Let's see, input frame range, output frame range. Yep. So what we could do is do it by... All right, let's do this 144. Should just be normal. Yep. And then if we do the speed... Let's see here. Oh, yeah, that's working great. It's going great. Everything's great, guys. Don't worry. All right, let me think about this here. Let's see. Really thought that would work better. Let's see here. thought that they had made this work so much better. I'm all confused. Oh, yes. I think that would be one thing we would need is ID attributes for these. Yep, that we would need. I think it should still be okay with reseeding. Let's see. We'll see. I think it's reseeding. It's not liking that, so let's just try this here. There we go. I think that was the problem. All right. One small change there. Let's see. That. Yeah, you can see where the sim's going to. It's only to right here, right? It's kind of interesting. And I think you could animate this speed. I'm not sure off the top of my head. Sorry, this is I'm just doing this on the fly, so please, your patience. All right, let me just set this to be manual for a second so it's an update. And let's... Oh, actually, that's not what I meant to do. Auto update's fine. I'm going to turn this off so it doesn't resim. So let's see. So let's have it slow down. So yeah, let me do this first, and then we'll take a look at that because I have a feeling it's going to break that, but I think there's ways to get around that after the fact. I'm not sure if it'll work with a fluid compress or not. So let me just make sure that it's working. But I think the problem might be that it's packed. So you might have to unpack it to get it to do that. So what you might do in that case is you might skip this step of fluid compressing and cache it, and then you could retime it because that's gonna give you more data to work with. But let me just see how this works first. But yeah, it's a good question. I'm not 100% sure if it'll work, but just want to make sure this is gonna do its thing first. So, all right, so let's do a speed ramp here and see if we can do it. So at 36, go from speed 1. Here we'll go to speed, I don't know, 2.5. Let it fall for a little bit slowly. It's not liking that so much. Maybe I need to add more substeps in, possibly. Man, they changed a lot of these. That's different. They're all these retime nodes now. I'm just trying to think of what the solution is here. Maybe I'm just going too far with it. Let me just see if I can do it. 0.5. I don't know why that's working. So Oh, you know what? I wonder if it's because if it's because I stopped the simulation, if that was freaking it out. Let's just try this. And then we'll have it speed back up here to 1. I don't know. I don't know if this will work or not. Let's try it. All right, let's see. Well, that definitely worked. Didn't freak out like it was before. So the trickiest thing with retiming is the interpolation between frames, right? Like the subframe part of it. That's weird. It doesn't seem like it's going full speed after it slows down. That's really weird. Oh, I think it's just playing weird. Let me make another flipbook of that, just out of curiosity. I think it's just playing back strange. It's not like playing back full speed. I mean, the reseating is definitely not great. I mean, it's working. It's not incredible, but it's working. You might want to turn off reseating. Probably would be helpful. Okay, so the reason that that's working pretty well, and the jittering is happening because of the reseating. That those particles that you're seeing jittering is because they're not available on the next like frame or whatever. So what it'll do is it'll interpolate between integer frames here, I'm pretty sure, and adding in the like really I probably only needed 4 substeps here, because if we're going down to a quarter, that should be fine. In fact, I could do another thing to see if that works any better. Yeah, I mean, it's fine. Works fine. So yeah, that's the trickiest part is interpolating those in between frames. So the ID helps with that, but with the points disappearing, that's where you're getting those like weird little jitters and stuff like that, and some of those extra points. So you could fix that by turning off reseating. If you're doing a slow, like a simulation like that anyways, that's like a splash or something like that, you're going to probably want reseating off anyways, because you're going to get tons of flickering if points are coming in or going and things like that. So so that's working. Let's see what happens here if we do this. Not sure what's going to happen here, but let's take a look. Yeah, there we go. That's looking great. Yeah, you can't do it on that. Let's see. What if we do particle? Fluid surface. And what we can do with this is output the particles. Is this also going to output the surface? No. Yes, it should, I thought. Let's see if this works. Can't say this will work or not, but we'll see. Okay, that looks like that would work. So what you could do here is you could cache this, right? So we could do a file cache. Let's double check this here. We'll save this. Let that go through and cache those last few frames. I should have used the save to disk in background because then I could have actually worked while this was going. Yeah, no problem, Zach. I'm glad to go through that. I think it's interesting. It's a good question for sure. Like I said, a lot of commercial stuff is always like, hey, how can we slow that water down? How can we make that splash like super slow mo? It's like, can we not? Can we just make it a little easier so, just actual simulation of fluid is enough? Maybe it's always something, right? But yeah, these should work with the fluids and the volumes. I know that they've tweaked these quite a bit to work a little bit better than they used to. It used to be a real pain in the butt. Yeah, see? Now that's not great. Okay. Let me think here. So I'm going to try one more thing here. So this is a retime. Let me do a time blend. Because what this should do is this, at least the way it used to work, a time blend would basically add in between frames for this. So let's just do this to 4 and then go down here to the retime and see if this works. Yeah, so what's going on here, and I'd have to look into this more maybe, is the problem is that the file cache is writing out integer frames, right? And the workflow that you've got coming from, like the stream that you have coming from this DOP network can have in between frames, right? This can have subframes, right? That's simulations have subframes. So it's fine with simulating subframes. And the problem is that once you hit this file cache, you'd have to save those substeps here, which is costly and pointless. So there's got to be a way to time blend that back out, or maybe this is something, I don't know. Watch this just works, right? I don't know. Don't know how this works. Okay. Oh my gosh, if this works, that's going to be ridiculous. I think that worked, actually. The only thing that it's not happy about is these compressed fluid surfaces. So if we just turn the particles on, this should work just fine. So use the lab simple retime. You even get a little ramp in here. Ay. I swear. These guys are out of their minds. The labs team is, oh, they're so great. I don't understand how they can do this stuff. I'm kind of curious what's going on in here. Time blend, then a time shift. So we're just using this. So yeah, this is the old time blend, I think. Yeah. So what's going on there? Time blend. Can I get the old one? Nope. I don't understand why that's not working as well. Well, this simple retime is sure simple. I mean, that's working great. So check out the labs tools, simple retime, and looks like you'll get some nice animation there. Let's see what this looks like. I'm sure it'll animate just fine. I mean, that's pretty smooth. Turn off that reseed. It'll even work out of the box after caching. So what that's doing inside of there is exactly what I was mentioning was, and I'm not sure why this retime isn't working the way I would expect it to, but basically what this is doing, let's just allow editing of content so we can see this easier. The time blend is basically saying, hold the first frame at 1, hold the last frame at 240, and interpolate in between. You could even do something like that. Maybe the voxels would blend. I don't know. And then the time shift, this is basically just adding it, using this ramp to drive what frame you're working on, basically, and going through it that way, which is smart and very good. And it works really well. So, yeah. And again, the little popping and stuff like that. Yeah. So, exactly. You wouldn't want to cash out more than you need, really. This method would let you sim in real time, right? So I sim this waterfall in real time, and it would allow me to sorry, I'm just making sure my mic. I'm just thinking, oh my God, is my microphone working properly? It would let you sim real time and then slow down after the fact, right? And the whole point of being able to sim in real time and not having to sim with sub steps is the same. So think about doing high speed photography, right? That's usually your best way to think about this process, right? If you wanted to take a picture of a waterfall and slow it down 25%, what would you have to do? You'd have to take video of that waterfall at 4 times the frame rate. So that would be 96 with 24 frames a second. Yeah. So not too crazy, but let's say you wanted to slow like this down to like a 10th, right? That means you'd have to film that at 240 frames a second, right? So similarly, as difficult as that is to do with high-speed photography, it's just as difficult to do and costly to do with simming this at, let's just see what this would be like if we simmed it at that other resolution, right? So here's our sim, right? We can easily take this and say, let's do, we could add in 4 substeps, right? So that would be simming it at 96 frames a second. We'd have to save those substeps out as well, which would take up more space as well. But let's just see how this goes simming wise. So here we go. So it might not be too crazy, right? We're getting about 1 frame a second, right? And it's going to go down from there. Let's see what we're getting at first. So this is 1 frame a second. Let's go back up and just see here. 1 substep. See how this is. Yeah. So it's 4 times slower, obviously, right? And this is a very low res simulation, right? This is just basically a test. Um, and so if we looked at this and said, oh, we're going to go to 10 now, 10 substeps. And let's just say we wanted to do this at like a real resolution. Where is it here? There we go. Say we wanted to do this at like 0.05, which is like not even that dense still. Like it's fine. It's that's 124,000 points for this right here, which is not even that much. It's like, let's say we want to start simming this. All right, now we went up a little bit in resolution and did 10 substeps to get us at like that 240 frames per second kind of look. And we're now at 31 frames per minute. So we've gone past the frames per second, and this hasn't even started. Once it starts falling, that domain starts stretching, right, and becoming bigger and bigger. So it's larger and larger that it's calculated. So this is right now at 13.9 frames per minute, and we haven't even started in the falling section, right? So this plus then the file savings that you're going to have to do of saving all those substeps is the reason why you would want to sim something like this at real, at a real speed, and then like at full speed, and then slow it down after the fact. Now that is obviously much more difficult, and there are some caveats there, but that's your benefit. So it helps in a multitude of ways. And you could always say you wanted to slow something down a lot. You could run it at like a couple global substeps and save out a couple subframes just to give yourself that little bit of extra flexibility so you're not interpolating as much as you were previously. The one thing to think about with that too is just like with motion blur, right? If you're doing motion blur, if you have something that's moving in a curve, you can only have your blur go as many frames as you're sampling, right? So if you're sampling a frame in between the two, you're going to get, like in the curve, it's going to go up and then over, right? If you do maybe 3, it's going to get 1, 2, 3, maybe like that. And the more and more samples you get in between, the smoother it's going to get. So if you're interpolating between 2 points, right, that are moving, in a curve or something like that, it's going to give you a much better curve just to add in that one extra sample to then interpolate between, because these are really just linear interpolations between those. But we're talking about, a ballistic force here, like something happening ballistically. So it's not this, like, it's not getting curved really. It's kind of just falling in this like slow arc kind of thing. So it's a little bit easier to, I think, to have those interpolations in between without having to worry so much about, seeing some weird like lines or whatever. But yeah, so that's kind of the answer there. But no, it's a great question. It's a cool thing to get into, especially at the end of this, when you're maybe, wanting to bring this into whatever, any other, maybe stylize it even more. So it's definitely a cool idea. So, yeah, I think that's where we're going to end for tonight. It's starting to get a little late for me here. Yeah, you guys have been listening to me talk enough. So, yeah, if there's any other questions that you guys have, before I hang everything up here and get on to going to bed, I'd be happy to answer them. There's always the Discord that you can drop things in there in the chat. And I also just updated the website to add in a little calendar underneath where the streaming information is, just to show what I have my schedule looking like ahead of time. So you can see it. Right now it's just for Wednesdays. I'm switching everything over to Wednesdays officially. So that's going to be my day now to stream. For whatever reason, Tuesdays have been tough for me, and Wednesdays have, like today was flawless. So last time, I think I streamed on last Tuesday and had issues. I don't know. I don't know what's wrong with Tuesdays in the northern Buffalo neighborhoods, but there's something network going wrong. So, yeah, we're going to do Wednesdays instead. So, yeah, no problem. Yeah. Thank you for following along. And, Yeah, you guys always please reach out through Discord. I mean, I'm in no way the expert on these things. You know, we're all here kind of learning together. So I didn't give my normal caveat at the beginning, but always love hearing from anybody, whatever, you know, level you're at, whatever questions you have, they're always welcome here. So I want this to be a welcoming place for all questions of all kinds. So, you know, I don't have all the answers, but we can certainly try to figure it all out together. So, yeah, well, great. Well, thank you guys so much for joining me tonight. Again, HoudiniHangout.com has all the information if you want to get connected on Discord, or follow the stream on YouTube or Twitch. Maybe you found it in one place and you'd rather watch it somewhere else. They're both an option. So, yeah, thank you guys so much again for joining, and I will be on next week around the same time. So I will see you guys next week, hopefully. Have a great night. See ya.